Welcome, my friends. The most common thing to input into a function is a constant. For example, consider f of x is equal to x squared minus 6. We could find f of 2 by plugging 2 in for x into the function. We would get f of 2 is equal to 2 squared minus 6, which simplifies to 4 minus 6, or negative 2. But we can also input variables into functions. So we could find f of 5a. This just means anywhere you see an x, put in 5a. We have f of 5a is equal to 5a in parentheses squared minus 6. Since the square is around both the 5 and the a, they need to each be squared. We have f of 5a is equal to 25a squared minus 6. What about g of x is equal to x minus 4 divided by 3x plus 5? We want to find g of x plus 2. This just means anytime you see an x, replace it with x plus 2. We have x plus 2 minus 4 divided by 3 times x plus 2 plus 5. Simplifying the numerator, we have x minus 2, as 2 minus 4 is equal to negative 2, and simplifying the denominator, we can distribute the 3 to get 3x plus 6 plus 5. Further simplifying the denominator by adding 6 and 5 together, we have x minus 2 divided by 3x plus 11, which is our final answer. Let's try a few more. We have f of x is equal to negative 3x squared plus 2, and we want to find f of b plus 5. Anywhere you see an x, replace it with b plus 5. We have f of b plus 5 is equal to negative 3 times b plus 5 squared plus 2. Remember that x plus y squared is just x squared plus 2xy plus y squared if you were to FOIL it out. We can simplify b plus 5 squared using this formula to get b squared plus 5b twice, which is just 10b, plus 5 squared, which is 25, all in parentheses, plus 2. Distributing the negative 3, we have negative 3b squared minus 30b minus 75 plus 2. Combining negative 75 and 2, we have f of b plus 5 is equal to negative 3b squared minus 30b minus 73, which is our final answer. Okay, one last problem like this. We have g of x is equal to negative 7 divided by 2x squared plus 4, and we would like to find g of x minus 6. Plugging in x minus 6 anywhere we see x, we have g of x minus 6 is equal to negative 7 divided by 2 times x minus 6 squared plus 4. FOILing out x minus 6 squared using the same formula as before, we have x squared minus 6x twice, which is minus 12x, plus negative 6 squared, which is 36. Distributing the 2, we have negative 7 divided by 2x squared minus 24x plus 72 plus 4. Combining the constants of 72 and 4, we have negative 7 divided by 2x squared minus 24x plus 76, which is our final answer. Okay, next we're going to talk about an application of variable inputs to functions, which is called the difference quotient. The difference quotient tells us to take f of x plus h and subtract f of x, and then divide by h. I'm labeling the difference quotient as dq here, not to be confused with Dairy Queen, just as an easy way for me to refer to this quotient when using it. This might seem kind of like a weird thing to calculate, but it's actually a very useful quotient to find. This quotient is the average rate of change of the function over an interval. It is very important in the calculation of something called the derivative that you will see if you take calculus. Let's look at an example. Say we have f of x is equal to negative 7x plus 3, and we would like to find the difference quotient. Let's start by finding f of x plus h. We plug in x plus h anywhere we see an x. We have f of x plus h is equal to negative 7 times x plus h plus 3. This can be simplified by distributing the negative 7 to get f of x plus h is equal to negative 7x minus 7h plus 3. Now we can plug into the difference quotient. We can copy f of x plus h to the numerator, and then we need to subtract f of x. But since we need to subtract the entire function f of x, we will need parentheses. The first part is f of x plus h, and the second part is f of x. We can distribute the negative sign to get negative 7x, which is just positive 7x, and then we need to subtract 3. If you've done this right, everything without an h should cancel. We have negative 7x and positive 7x, which cancel, and positive 3 and negative 3, which also cancel. This leaves us with negative 7h divided by h. The h's cancel, and we are left with negative 7, which is our final answer. Let's look at another example. Say we have f of x is equal to negative 2x squared minus 3x plus 4, and we want to find the difference quotient and then simplify as much as possible. The first step will be to calculate f of x plus h. We have f of x plus h is equal to negative 2 times x plus h squared minus 3 times x plus h plus 4. Foiling out the squared term, we have negative 2 times x squared plus 2xh plus h squared. And then we can distribute the negative 3 to the x and the h. We have negative 3x minus 3h plus 4. Next, we can distribute the negative 2. We get negative 2x squared minus 4xh minus 2h squared minus 3x minus 3h plus 4. There's nothing that can be combined, so this is our expression for f of x plus h. Let's plug into the difference quotient formula. The formula tells us to start with f of x plus h, so we can copy that to the top of the fraction. Then we must subtract f of x, but the entire function f of x must be subtracted, so we need to put it in parentheses. This is all divided by h. Distributing the negative sign, we have 2x squared plus 3x minus 4. I'm going to copy this over to a new page. Now, if you've done this right, everything that does not include an h should cancel. We have negative 2x squared and positive 2x squared, which cancel. We have negative 3x and positive 3x, which also cancel. And the constants of 4 and negative 4 will cancel. We are left with negative 4xh minus 2h squared minus 3h, all divided by h. Since all three terms have an h in them, we can factor out the h. We have h times negative 4x minus 2h minus 3. The h's will cancel, and we will be left with negative 4x minus 2h minus 3, which is our final answer. Alright, let's try one more problem. We have f of x is equal to x divided by x minus 3, and we want to find the difference quotient. Let's start by finding f of x plus h. Anywhere we see an x, we can plug in x plus h. We have f of x plus h is equal to x plus h divided by x plus h minus 3. Let's plug into the difference quotient formula. We have f of x plus h on the numerator, which is x plus h divided by x plus h minus 3, and then we must subtract f of x, which is just x divided by x minus 3. This all needs to be divided by h. Now, this might look a little bit intimidating to simplify, but the trick is to multiply the entire expression by the least common denominator divided by itself, which in this case is just the combined denominator of each of our terms, or x plus h minus 3 times x minus 3, all divided by itself. This will end up clearing the fraction in the numerator. The denominator is relatively straightforward. We just have h multiplied by that whole denominator, which is x plus h minus 3 times x minus 3. In the numerator, we need to think of x plus h minus 3 times x minus 3 being distributed to each of our terms inside the parentheses. For the first term, the x plus h minus 3 will cancel, but we will have the x minus 3 left over, so that we will have x plus h times x minus 3. For the second term, the x minus 3 will cancel, so that we are left with x times x plus h minus 3, which all needs to be subtracted. Now we can simplify. Foiling the first term in the numerator, we have x squared minus 3x plus hx minus 3h, And distributing the second term, we have negative x squared minus hx plus 3. Now comes the fun part. Almost everything cancels. The x squared terms cancel, the hx terms cancel, and the 3x terms cancel. All we have left is negative 3h on the numerator. The h cancels with the h on the denominator, and we are left with negative 3 divided by x plus h minus 3 times x minus 3, which is our final answer. Alright, my friends, that wraps up our video relating to inputting variables into functions and using the difference quotient.